In this video, we will learn how to write an assembly language program to enter and display 16-bit number. So in this program, we have written the first line of our code is dot model small. So small indicates that it is a memory model and we can declare this data and our code segment within only one program segment. So this is our data segment and this is our code segment. So in that data segment, we have declared the two strings, that is message 1 and message 2. And this string can be declared as a 16-bit number with the help of these DW directives. So DW stands for define word. And we have taken here 10, 13 for taking the control for the start of the next line of our statement. And that is given in that particular variable. So in the first variable, that is message 1, declare as enter 16-bit number. And message 2 can be declared as 16-bit number each. So these two statements are written here as a message for printing the data on our console. Now next one, in that code segment we have written that is dot startup. So with the help of this dot startup, we are initializing our all data segment and all code segment that are declared under the program segment. So this data segment and this code segment will be initialized here and our program execution will begin. Now next one, we have written here move age, 09H, load effective address, dx, message 1 and integer 21H. So these three lines are written for printing the data on our console. So this 09H is the DOS interrupt. So whenever we have to print the data or our message on our console as the output, that time we have to call this DOS interrupt, that is 09H interrupt, and we have to copy this value into our AH register. Then we are loading the address of our message 1 into our DX register. So for taking the address from message 1 into our DX register, we are using that instruction, that is load effective address. So LEA stands for load effective address, and it will load the effective address of our message 1 into our DX register. Now next one, our next part of our code is integer 21H. So with the help of this integer 21H interrupt, we are displaying the contents of message 1 on our console. So we will see this execution in our emulator screen. Starting with execution of our code, it will be started with our dot startup line. So I'm clicking on that now single step mode of our operation. So it will redirect to the next line of our code and it will copy the contents of 09 into our AH register. So we are writing here move H, 09H. So this 09H will be loaded it into the AH register. Then we are loading this effective address of our message 1 into our DX register. So our message 1 value is 0000H, that is the effective address, and that will be loaded here in our DX register. So our now DX becomes 0000. Now the next one, with the help of this integer 21H interrupt, we are printing the data on our console. So our message 1 consists of enter 16-bit number. So this data will be printed on our emulator screen. So we have just printed the message, that is enter 16-bit number. Currently we have not entered any value on our console. So now we have to enter the 16-bit number on our console. So that we have to take the input from keyboard. So for taking the input from keyboard, we require 01H interrupt. So in the next line that is highlighted in yellow color, that is written as move AH, 01H. So whenever you have to call the DOS interrupt, that time, first of all, you have to copy the contents of your DOS interrupt, that is number, into your AH register. So for taking the data from keyboard, we require the DOS interrupt, that is 01H. So we have written here move AH, 01H. So that 01H value will be loaded into our AH register. So this part of code will be written for taking the data for input, and our first digit will be taken as the input. Now see, I'm clicking on that single step mode of execution, then it will be redirect to the integer 21H. And after entering this, it will display waiting for the input. So it will asking for the user to enter the data from the keyboard. So how it will happen? We have used this interrupt, that is DOS interrupt 01H, and with the help of this DOS interrupt 01H, it will inform to the user that value should be given from the keyboard. So I am entering only first digit of my number. So I want the number, that is 2345. So out of that 2345, I am entering here only 2. And after pressing this 2, I have to leave the control from my keyboard. Then I am clicking on that single step mode of operation. Then it will be redirect to the next part of our code, that is subtract AL, 30H. So why there is need to subtract the value 30 from AL register? Because you can check that whenever I am entering here 2, that time your value will be added, that is 2 plus 30, and it will become 32, and that hexadecimal value of our 2 will be loaded in our AL register. So whenever I am taking the data from the keyboard, that time I am entering the value on our console, and our console will understand the value, that is 2. But our register can understand the value only in the form of hexadecimal number. That's why they are taking the value 32, and it will be loaded it into the AL register. Now we require number 2. We don't require the number 32. That's why we have to subtract AL, 30H. So after subtracting this value, it will become 02. Now our contents of AL becomes 02. Then the next part of our code is move CL, 04H. So this 04 is loaded with our AL CL register. Then it will check that the contents of now CL becomes 04. Now the next part of our code is SHL AL, CL. So now check that what is our content in AL and CL. AL consists of 02 and CL consists of 04. Now we have to perform the shift left operation with 02 number with 4 times. So now we will check how this will happen and what will be the contents of AL register after performing this shift left instruction. Now what is the contents of our AL register? That is 02. So I am writing here AL is equal to 02 and our contents of CL is equal to 04. And we have to perform this shift left instruction with 4 times. So I am writing here SHL AL, CL. So now it will become SHL 02, 04. So now we have to shift this 02 with 4 times. So first of all, I need to write the binary number of our 02. So we can consider it as a BCD number, and we have to convert each and every bit in binary format. So for 0, we can write here 00, 00 and 0010. So this is the higher nibble and this is our lower nibble. And we are shifting this data on the left side, then we will get this value, that is 0, then 0, then 0, and then 0. This is again 0, this is 1, this is 0, and here it is 0. So it will happen with the first time. Then second time we get this value as, this is our 0, then 0, 0, this is also 0, then 1, then 0, and 0, and 0. Then third time we got this 0 here, then 0, 0, 1, again 0, 0, this 0, and last one is 0. And the last time, the fourth iteration will be our 0, then 0, this 1, and this will be 0, again 0, 0, 0, and 0. So we have completed with our shift left instruction, and after performing this shift left instruction, we will get the result as 0010 and 0000. So whenever I am again considering this number, it as 0010 is nothing but 2 and 0000 is equal to 0. So we are providing the input as 2, 3, 4, 5. And out of that 2, 3, 4, 5, we have entered this 2 on our console. So first of all, we will consider this 2, 3, 4, 5, and from that 2, 3, 4, 5, we are considering only this pair, that is 2, 3. And out of that 2, 3, we are considering this number as a 2 for our input, that is input first digit. So why we are shifting this data on the left side? For 23, if we are considering it as only 23, then 23 is nothing but 20 plus 3. So that's why we have done with that shifting of left operation for 0 to 4 times. Then we will get this 20. Now next one, we have to take the input as a second digit. But before that, we have to copy the contents of AL into our BH register. So why we are copying this data into BH register? Because later on we have to add this 20 with our data 3. So now the contents of 20 will be stored in our AL register. Now we will check this data with the help of our emulator screen. So see here, whenever I am pressing on that single step button, then this data will be loaded here and the contents of AL will be updated with the 20. And now we are copying the contents of AL into our BH register. So previously our BH register is 00, and after executing this data in our single step mode of operation, our BH becomes 20. Now it will be redirect to the next part of our code, and the next 4 lines, that is line number 18 to line number 21, will be written for inputting the second digit from the keyboard. So whenever we have to take the input from the keyboard, that time we are taking this 01H as a DOS interrupt into our AH register. Then with the help of integer 21H, it will be asking the data that is input from the keyboard. So now see, here the line will be blinking and it will ask the input from the keyboard. So I am entering this 3 here from the keyboard and I am pressing the control from the keyboard and I am leaving the control from that keyboard. And you have to click on that single step mode of our operation. So here check that whenever I have pressed this 3 from the keyboard, that time the hexadecimal value of our 3 will be loaded in our AL register. So the hexadecimal value of our 3 will be 33 and that contents are loaded in our AL register. So now our AL becomes 33. So we require only 3 as a number. So that's why we have to again subtract AL comma 30H. So after subtracting, it will become 03. Now we got the number that is 20 in our BH register and 03 in our AL register. As we have already seen that we have to add this 20 plus 3. So for taking the number 20, we have performed the shift left operator. And with the help of this shift left operation, we are taking this number as a 20. And now we are adding this 20 with number 3. So that's why we have written here add BH comma AL. So after adding this, the addition will be performed and the result will be stored it into your BH register. So now see here, your BH becomes 23 and it will be redirect to the next part of our code, that is move AH comma 0301H. So again we have to taken the third input from the keyboard. Then we are again copying this value of 01 into our AH register. Then with the help of integer 21H, it will be asking the user to take the data from the keyboard. Now I have to enter here 4 and again this will be added, that is the hexadecimal value of our 4 will be added in our contents of AL register. So the contents of our AL register becomes 34. Now we have to again subtract the value 30 from that AL register. So that's why we have written here subtract AL comma 30H. So now this value becomes 04. Now the contents of our AL becomes 04. So here we have to taken this counter value again 4. That's why we have written here move CL comma 04H. So now the contents of CL becomes 04 and the next part of our code is SHL AL comma CL. So check that what is our content in our AL register, that is 04, and what is the contents of our CL register, again it is 04. So we are performing the shift left operator with our 4 with 4 times. So see here how this will be executed. Our contents of AL is equal to 04 and our contents of CL is also 04. And we are performing this SHL instruction with our AL register comma CL. So our SHL consists of two parameters, that is AL comma CL. These are the two registers are given and we are writing here 4 comma 4. So here check that we have to shift this number 4 with 4 times. So first of all you need to write the binary number for our 04. So what is the binary for our 04? That is 0000 and 0100. So this is the binary for our 4 and we are shifting this data on the left side. So we will get first time as, that is 0, then 0, then this is 0 and this is 0. Then 1, then 0, 0 and this is our 0. Again it will become 0, then 0, then 0 and 1. This is also 0, then 0, then 0 and 0. So this will happen second time. Now again we have to do it for third time as well as fourth time. And we will get the values as 0, then 0, this is 1 and this is 0. Again it will be 0, then 0, 0 and last one is 0. And on the last time, that is the fourth time, the iteration will be 0, then 1, this is 0 and this is 0 and the last part will be 0, 0, 0 and 0. So now we got our result and the contents of our AL register will be 0100 and 0000. So we can consider this 0100 will be 4 and 0000 will be 0. So what input we have to taken from the keyboard? That is 2, 3, 4, 5. And we have already completed with this 23 and 23 we have taken it as 20 plus 3. Same like that, we have to taken this number for our 45 and we have to take the numbers for 45, that is 40 plus 5. Okay, got it? So that purpose we have shifted this 04 that we got in AL register on our left side, and we will get the value that is 40. And that number 40 we have to copy it into our AL register, because we have written here SHL, AL, CL, and with the help of SHL instruction, we have shifted the contents of AL on the fourth time on the left side. So now our contents of AL becomes 40H. Now we are shifting this value, we are copying this value from AL to our BL register. Now our BL becomes 40H. Now you can check that this output with the help of our emulator screen. So I'm clicking on that single step mode of operation and our instruction will be executed as SHL, AL, CL. So previously it will be 04 and after shifting it will become 40. Now we are copying the contents of AL into our BL register. So our contents of AL is equal to 40 and we are copying the data into our BL register. So it will become 40. Now we have to take the 4 digit from our keyboard. So that's why we have to call the DOS interrupt with the help of 01H. So this value will be copied into our 01H into our AH register, and with the help of integer 21H interrupt, we are taking the data from the keyboard. So now I have to enter number 5 here and I have to leave the control from my keyboard. So whenever I am pressing 5 from the console, the hexadecimal value of our 5, that is 35, will be loaded in our AL register. So it will be added as a 35. We have to subtract 30 from that 35. That's why we have written here subtract AL, 30H. So after subtracting, it will become 05. Now check that in our BL consists of value 40 and our AL consists of value 5. So we have to add these two values together. So it will become 40 plus 5 is equal to 45. So that's why we have to write the instruction that is add BL, AL. So after executing this, it will become 45 and the contents will be stored into the BL register. So now we have completed with our taking the input from a keyboard. The next part of our code is we have to display the 16-bit number on our console. The first 3 lines are given, that is for displaying the message on our console. So the message 2 will be 16-bit number is. So we are displaying this 16-bit number is message on our console with the help of this 3 line of our code. So first of all, we have to call the DOS interrupt, that is 09H in our AS register. Then we have to load the effective address of our message 2 in our DX register. So our DX becomes 0016. And with the help of integer 21H, the 16-bit number is that message will be printed on our console. Now, what is the next instruction? Move CH, BH. So what will be the contents of our BH? It is already there, that is 23. So that data we are copying it into 23, that is in the CH register. So this move is the data transfer instruction and we are transferring this BH register data into our CH register. The next part of our code is AND CH, 0F0. So now we can check that how it will be executed. So see here our contents of CH is equal to 23 and we have to perform this AND operation with 0F0. So for F0 we have to return the binary number and for 23 also we can write the binary number. So for 2 we can write here 0010. And for 3 we can write 0011. Then for F0 we can write it as 1111 0000. So after performing this AND operation, we will get higher nibble of our data. So we will get this 0010 and 0000. So our result of the operation becomes 20. So for displaying the number 2345, first of all we have chosen this first two digit from that number, that is 23. And for displaying also we can take this number 23 and we are performing this AND operation. So why we have performed this AND operation? So for this 23 we have to take this number as a 20 and 3. And we are adding this 20 plus 3 later on in our code. So check that after copying this data 20 on our CH register, then we have to move the contents of CL as a 4. So after performing this moving instruction, we have to perform the shift right instruction. So what is this shift right instruction? We have to perform this SHR CH, CL. So now we can write here SHR CH, CL. So our CH consists of 20 and our CL consists of 04. So now we are performing this shift right operation. So the contents of 20 we can write it as 0010 and 0000. And we can shift this data on the right side and we will get this value as 0, 0, 0, this 0 here, then 1, 0, 0 and 0. This will be shifted first time, then second time we will get this value as 0, then 0, then 0, then 1. Again it will be 0, then 0, then 0 and 0. Third time we will get this value 0, 0, 1, then 0. Again we got 0, 0, 0 and 0. And on the fourth iteration we will get this value as, that is 0, this is 1, this is 0, this is 0, then 0, 0, 0 and 0. So after performing this operation, we will get this data 0000 and 0010. So we can write it as 0 and 2. So this data will be stored in our CH register because our destination register is CH. So after performing this SHR instruction, our result of the operation becomes 02. So let's check that this data on our emulator screen. So we are here at AND CH, 0F0 instruction. I'm clicking on that single step mode of operation. The result will be updated here and our CH register becomes 20. Now we are copying the contents of CL, that is 04. This will be updated here and we are performing the shift right instruction with CH, CL. So previously the CH contents will be 20 and after performing this instruction it will become 02. So now we have to print that 02 on our console, that is 2 will be printed on our console. But here check that our CH register consists of 02. Whenever we have to print a value on our console, that time we require the hexadecimal value of our number. So what is the hexadecimal of our 2? That is 32. So that's why we have to add 30 into our CH register. So we have right here add ch comma 30h. So that will be added here, that is 32, and this 32 will be printed on our console with the help of our DOS interrupt, that is 02H. So we have to load this 02 into our AH register, so that we have written here move AH comma 02H interrupt. And with the help of integer 21H, we have to print this 32 on our console. But here you can check that 32 will not be printed on our console. 32 is the hexadecimal value of our 2. So 2 will be printed on our console with the help of this integer 21H. Now you can check that what is the next line of our code, that is move ch comma bh. So check that what is the contents of our ch and what is the contents of our bh. Ch is 32 and our bh is 23. So again we are copying this 23 into our ch register. So now our ch will be updated here and it will become 23. Again we have to perform the AND operation with ch comma 0f. So let's check that how it will be executed. So now the contents of our ch is equal to 23 and we are performing this AND operation with our 0f. So 23 and that will be ANDed with our 0f. So previously whenever we require number 2, that time we have performed this f0 AND operation. That time we require the number 2. Now we want number 3 from that 23. That's why we have taken this 0f AND operation with our number 23. So first of all write down the binary, that is 0010, then 0011. And for 0f we can write it as 0000 and 1111. So after performing the AND operation, we will get this value, that is 001, 0000 and 0011. So the result of the operation becomes 03 and that result will be stored it into the destination register. So what is my destination register in that instruction? That is CH register. So the result of the operation will be stored it into the CH register. The next one, you can check that what is the instruction, that is add ch comma 30h. So we will move to the emulator screen and you can check here the contents of ch will be updated here, that is 03. Now you have to display this 3 on our console. But how it will be displayed on our console? First of all, we have to take it as a 33. That is the hexadecimal value of our 3. So for taking the number 33, we have to add the 30 with our CH register. So now our CH register becomes 33. After writing this instruction, that is add CH comma 30H. Now we have to print this value on our console. So printing this value on our console, we have to take this number, that is move DL comma CH. So I'm writing here move DL comma CH. So the contents of our CH register will be loaded on our DL register. So now our DL becomes 33. So how we can print this value on our console? If you have to print the value from the register to our console, we have to call this DOS interrupt, that is 02H interrupt. And we are copying this 02H interrupt on our AH register. Whenever we have to print the data from the register to console, that time we have to copy the contents of our message, contents of our data and our variable into our DX register. So from that DX we have used DL register for storing our data. So now we have to print the message 3 on our console. That number will be printed on our console with the help of DOS interrupt, that is 02H interrupt. And after pressing the single step button, and that integer 21 instruction will be executed and 3 will be printed on our console. Now we have print 23 on our console. Now we have to print 45 on our console. That is the next part of our number. So first of all, we have to copy whatever the contents are there in our BL register, that is 45, in our DH register. So our DH will become 45. So now let's check that what is the next instruction is given, that is AND DH comma 0F0. So let's begin with that execution part of our instruction, that is AND DH comma 0F0. So see here, our DH becomes 45 and we have to perform the AND operation, that is 0F0. So whenever I am performing this AND operation with F0, that time we are performing the AND operation and it will take the higher nibble of our data. So for 45 we can write it as 0100 and 000101. And after performing the AND operation, you can write it as 1111 and 0000, and you will get the value, that is 0100 and 0000. So the result will be 40. So here, why we have performed this AND operation? Because our number is 45 and we have to taken it as 40 plus 5. That's why we have taken this number 40, and your 40 will become 40 plus 5 later on this stage. So the first of all, our DH will be 40. Now what is the next line? So now we are here, that is AND DH comma 0F0. Now the next part of our code is move CL comma 04H. Then CL becomes 04. Now we have to perform the SHR instruction. So what is this SHR instruction? That is SHR DH comma CL. Now our contents of DH will be 40 and we have to shift this data 4 times on the right side. So how it will be executed? You can check that. So this 40 can be written as 0100 and 0000. And we have to shift this instruction on the right side. We have to shift this data, that is 40, on the right side 4 times. So in the first iteration, it will be 0, then 0. This is our 0 and this is 0. And next will be 0, 1, 0 and 0. Second time we will get this value as 0, then 0. This is our 0, then 0, then 1, 0, 0 and 0. Third time we will get this value as 0, 0, 0, 1. Then 0, 0, 0 and 0. And fourth time we will get it as 0, 0, 1, then 0, then 0, again 0 and 0. And the last one is 0. So now the result will be 0000 and 0100, that you can write it as 04. So now check that what is the next instruction, that is add DH comma 30H. So after performing this shift right instruction, our result will be store it into our DH register. So now let's check with that emulator screen. So check here. We are here on the right instruction, that is AND DH comma 0 F0. And after executing this instruction, your value of DH becomes 40. Then you are copying these contents of 04 into our CL register, that is CL is equal to 04. Then after executing this instruction, it will be redirect to the next part of our code, that is SHR DH comma CL. Now you have to perform the shift right instruction and it will become 04. So now you have to add this 30 into our 04. So it will become 34. Now the contents of our DH register becomes 34. So what is the next part of our code? Again, we have to copy the contents of DH register into our DL register, because with the help of DOS interrupt, 02H interrupt, we can copy the contents of DL register and that will be displayed on our console. So first of all, what is the first step? You have to copy the data from DH register to DL register. So now check that the contents of DL becomes 34. Then the next instruction is move H comma 02H. Then after using this integer 21H interrupt, we are displaying this 4 on our console. Now next one, the instruction is move DH comma BL. So the contents of BL will be, that is 45, that will be loaded in our DH register. So the contents of our DH register becomes 45. Now next one we have to perform the AND operation, that is DH comma 0FH. So see here, the contents of our DH register will be 45 and we are performing the AND operation with 0F. So in the first side of our operation, whenever we require this number 4, that time we are performing the AND operation with F0. Now we want this number 5 from that 45. That's why we are performing the AND operation with 0F. So first of all, write this number as a binary, that is 000100 and 0101. And for 0F, we can write it as 0000 and 1111. So after performing the AND operation, you will get the result as 0000 and 0101. So your result will be 05. So now you got the value 05 and that will be loaded in our DH register. So now our DH becomes 05. So see here, what will be the contents of our instruction? So the first of all, you can check that what will be the output after performing this AND operation. So see here, the contents of DH becomes 05. Then we have to add this 30 with our DH register. So after adding this data, it will become 35. Then we have to print this hexadecimal value 35 on our console. But our console can be display data 5. So how it will be displayed? The first of all, we have to copy the contents of DH into our DL register. And with the help of DOS interrupt, that is 02H interrupt, our data can be printed on our console. So the first of all, we are copying this data with our DL register. Then move H comma 02H and integer 21H, our 5 will be printed on our console. So we have successfully printed this 16-bit number on our console. So in this program, we have entered one 16-bit number, that is 2, 3, 4, 5, and we have taken 1 by 1 digit from the keyboard input. and we are displaying here 16-bit number each, that is 2, 3, 4, 5. So in this video, we have learned how to write an assembly language program to enter and display 16-bit number.